I'm happy, I guess, to have some more material to throw at developers when you have a chat about this topic with them. It's a very important topic that we are going to cover, and maybe with some surprises for you guys. So let's dive in. I've been using PostgreSQL for a long time. I began on the previous century, and I'm part of the contributors to it. I work at Citus Data, and I'm told by our marketing department that we have nice socks that I can throw in the audience if you want them. So usually it's if you ask a good question, I throw a sock, but if you just say, this talk is awesome, you will get a sock anyway. So be sure to yell something and I throw socks. Okay. See, there is one guy who knows the rules. And so, as mentioned before, I've been working on a PG loader. The idea of PG loader is that you can migrate from another database technology to PostgreSQL in one command line. It only needs two parameters, so your former database connection string and your PostgreSQL connection string. It will figure it all out by itself, figure out the schema, the data types, the casting rules, everything, the default values, the foreign keys, primary keys, indexes, etc. And it's pretty good at it. The goal when I wrote this tool is that there is a lot of open source software that I would like to use, but they're using MySQL, and I will not trust my data to that technology. It's personal, okay? And so, no, you don't have an excuse. If you're working with MySQL, you just run one command line and you can use PostgreSQL instead. So no excuses anymore, just use it. So, okay, let's dive in with data modeling. Data modeling is a very important part of using PostgreSQL because some databases technology around here are proud to be schemaless. We are not. We are not schemaless, and we need to see what it means. So this quote is from Rob Pike and from a book issued in the 70s, I believe. So it says that if you have chosen the right data structures and organized things well, the algorithms will almost always be self-evident. Data structures, not algorithms, are central to programming. Okay? So it's meant that application developers who are writing code, if you're writing Python code, then you know you need to think about how you organize the data in your code, like in a class, in a structure, in a name tuple, in something else, and how do you pass data along. That's the most important thing. In Java, it's about the same terminologies. If you're using Go, it's structs. If you're using C, etc., etc. But it's always the same idea that if your data in the code is well organized, then the code is easy to read and you don't have so many bugs. If the data is a mess, you have lots of bugs because anything you want to do is going to be complex to do when the data doesn't lend itself to being processed a specific way. It's exactly the same with database modeling. If you're having a really hard time writing your SQL queries, most of the time, it could be one or the other reason. The first reason usually is you don't know SQL very well, so it's normal that you find it hard to do because you're not there yet. The other reason is the schema is not adapted to your business case. So of course, every query you want to write is going to be hard to write. So if you have a proper schema design, then SQL is really easy to write. So in this talk, we're going to overview the classic rules that allow you to design a schema properly. Before we do that, I want to show some examples just to get your mind started. Because the rules are a little complex to handle. So data modeling, usually it revolves around data types, constraints. And when we say constraints in databases, so most people, we don't want to have constraints in our lives, right? We want to be free, do whatever we want to, whatever we fancy. Nobody likes, or almost nobody likes having constraints. So most of people, when we talk about database constraints, they're like, oh, constraints, it's boring. So I think the term should be changed. It's not a constraint, really, that you're having. It's a guarantee, a very strong guarantee for your data in the database. So we'll tell more about that in the more slides. But constraints is the technical term that everybody uses, but the one we should have in mind is guarantees. So how many guarantees, or strong the guarantees you have in your database you want to have. If you're schemaless, you have 0 guarantees. It's all up to you. That's why we are really happy with PostgreSQL to have data modeling issues and the schema, etc., because it means we have strong guarantees. And for implementing constraints, usually we use primary keys, foreign keys, checks, etc., etc. So a couple examples. This is a table where you would handle articles, like news articles. It's a really classic one with a primary key. And this schema is wrong, okay? Is it obvious for everyone why it is obviously wrong? Okay, so we'll get back to that later in the talk. So I'm just trying to tease you a little. This one is okay. It's a partial unique index example that I just copy-pasted from an example on Stack Overflow or something. So it's implementing toggles for like a UI for the users, and they can toggle it on and off. So they can enable it or disable it. And when it's disabled, you want to remember they did use it before and then they disabled it. So if it's currently have a value in disable that column, then you don't want, basically you're not taking care of it in the application. So you can say that you have a unique index on the toggles, but it only needs to be unique if it's not been disabled. Okay? Who knew you could do partial unique index in PostgreSQL? Yeah, not very, yeah, some of you. Okay, good. So it's a really nice trick to have. And another kind of a guarantee that we are going to see later is exclude using gist. So who's done that before in PostgreSQL? Okay, for the other guys, we're going to dive into that later in the talk. The goal of database modeling, the first goal is to avoid anomalies. So there are three possible kind of anomalies: insert, update, delete, basically. So update anomaly, this schema is wrong. The model is not good because you see in the same table we have the employee ID, its address, and a set of skills that are associated with the employee. But this employee, apparently, he moved in between where he learned how to be a public speaker and when he learned carpentry. He's now living somewhere else. So now we have two entries in the database that are disagreeing with each other. So which is the right one? What is the current address of this guy? Well, we don't know. We don't know, and why don't we know? Because the schema is wrong. We should have the address at only one place, not two of them. So how to make it happen, we'll see that later. So that's the update anomaly, because we have updated the address, and now we have two of them, and we don't know which one is the right one. Insertion anomaly is, let's say that you have a schema in the faculty for the professors who are giving courses. And so each professor might be given one or several courses. And this new one has been hired in the faculty, but it doesn't have a course yet. And with this model, we cannot even enter the information because it doesn't have a course yet. Okay? So it's obviously wrong, right? So that's insertion anomaly. You cannot insert the data with that model. And then, of course, the other side of it is the deletion anomaly. So now, if this guy is not doing that course anymore, you want to delete the line, but if you do, you forget about him. You don't have him in the system anymore, so he cannot show up at the office or whatever, I don't know, or it works exactly their system, but because he doesn't have a course anymore, he is not on the list anymore. So I think it's quite obvious for everybody why those schemas are wrong. So now we are going to try to explain the rules around how not to get that schema and some more. The thing that is central to database design is that, so I like this other quote to explain it, so I will read it out loud again. So it's from Fred Brooks, and he said, "Show me your flowcharts and conceal your tables, and I shall continue to be mystified. Show me your tables, and I won't usually need your flowchart because they'll be obvious." Okay? The database design should be that obvious. When you look at your database design, if you don't understand the business from it, usually it means it's not so good. It means that you've been lazy, maybe you implemented the database design the same way you did your object-oriented architecture in your software. But your software is going to be tasked with implementing a particular user workflow. So you take one user in the system. If it's a web application, for example, you're going to drive the user and enable the user to do something, like a particular workflow. And the code is all about that. But the database is guaranteeing the data, business models, guarantees, constraints, etc., for the whole system at one time. So it's not the same thing serving one user and making sure that the system globally is consistent. So your database is about the whole system being consistent, and your code is about allowing users to do what they have to do with your system. So there is few reasons why it should be the same model anyway. So practically for the tooling, some people would use graphical stuff, etc. So it's a very nice way if you are more visual. It's a nice way to basically to understand the problem set. But then what I usually do myself is I just write a SQL script, and I do begin and roll back. And so I needed that thing to fit on the slide, so it's a very small one. Usually I insert more things into the tables, and then I write some sample queries that I know I will have to use in the application. And again, if the queries are complex to write, I'm like, maybe that's not the right schema. If every query is easy to do, I'm like, okay, maybe I can go with that. And you see this trick here, rollback? So I think to this day, I'm not sure to this day, but PostgreSQL is the only one, or maybe one of the very few systems, where you can actually have transactions and DDLs. So you can create schema, create table, and then roll back, and nothing is there anymore. Okay? So in other systems that I won't name, but as soon as you do create schema or create table, then there is an implicit commit for the transaction. So when you do rollback, the system is like, there is no transaction running, which is the most scariest warning ever. It's like commit or rollback, and no, there is no transaction currently happening. What? Okay. So with PostgreSQL, you can actually do that, and so you can refine your schema as you go, because when you do rollback, you're back to a pristine stage again, so you can do it as many times as you want to, and you can change your mind like maybe 50 times in a day and play around with it and see what happens. You just run the script, and at the end, nothing happened. So you had some stats around at the end of it, some queries that are giving more information about the schema, and when you're happy with it, then you change that into a commit, you run it again, and now you have your database schema to play around with. Some people are using, I've heard tools called ORM, and they say it's object relational mapping, and almost every one of them that I had to have a look at is doing it wrong, because the R in ORM stands for relation, right? Relation is the result of a SQL query. So do you know that in the SQL standard, so we have select query, and we also have another query that is named table. So if you have a table, like in the previous example, category, if you do table category, it will dump the whole content of the table category, okay? So obviously a table is a kind of a relation. So if you have a table, you can use it as a relation, but it's only one a specific case for relations. It's not the general idea. The general idea is that any and every SQL query that you are using is defining a relation and can be used as a relation. That's why when you do a select with a from clause, in the from clause you can have sub-selects, because any select can be a relation, so it can be used as a from source in a query. Okay? So the ORM should be actually mapping the relation that is the result of the SQL query into your objects in the code. And that would be a good ORM to have. So if you're doing Java, have a look at Juke, G-O-O-Q. If you're doing PHP, have a look at POM, P-O-M-M. And there are others, there's programming languages that the two of them that I have in my mind. So if you're doing something else, find it. There must be a tool that is doing it the proper way. But if you have an ORM that is mapping the base tables to your objects in memory, well, you don't have a use case for that, really. So it helps no one, and it's complex to use, etc. And it's very, people would say that it's really hard to map those two things together. That's why I have this schema here. But it's actually because usually they do it the wrong way. If you try to solve the wrong problem, it's way harder than if you try to solve the problem you actually have. So the mapping should be done with SQL results. So that's what I want to say about ORM. So we're going to talk about database design and modeling and normalization, and I won't talk anymore about ORMs, okay? So that was the basis for database modeling. And the next step is, how do you know if your model is good enough or not? So we're going to introduce a set of rules that are really helpful to know that. Before I do that, any questions yet? No, maybe not. So nobody wants any socks, I guess? Yeah, some people do. I'm not good at aiming, so please figure it out. There will be more if people want more, later. So normalization, what does it mean? Basically, it's following a set of principles that are allowing us to think about the schema in a theoretical and practical way. Those are a few of the rules that are in a book from the 70s, 80s about the basics of the Unix philosophy with strong principles. And I like to use that because, as I said, the goal is really to have a chat with developers, application developers here. And Unix principles, they apply well to building software. And what I want to have people think about is that the same design principles that you can use to write software, you can use them to write your database schema. It's the same thing. So clarity, simplicity, transparency, robustness, that's nice goals that you want to achieve when you do a database schema. And because it's all about the schema, one thing is dry, don't repeat yourself. But I'm using also that slide as a warning. This topic is a little dry, so it's not that fun to talk about, but it's very important, so let's do it anyway. So who knows about normal forms? Yeah, so you know it's from the 70s, so everybody's like, yeah, we're in the 2000 something already, it's like stuff for granddaddies, but actually, you know, nobody said they're wrong now, so they're still very much, to this day, important to remember, figure out, and use. So when you design a database schema, remember about those rules and actually do them. So the first normal form, the target is that you don't have duplicated rows in the table. And no repeating groups, arrays, each cell is a single value. So I've seen many schemas, I've been doing consulting before, and many schemas where there is always this table with a comma-separated set of values. Because, you know, creating a new table in production was boresome, so they just added fields in a single field. And as soon as you do that, then SQL is going to be really hard, because SQL doesn't lend itself very well to that. And so those are the first rules. Second normal form, so the trick with the normal forms is to reach the next level, you need first to reach the first level. So if you want to be second normal form, you need to make sure you are compatible with the first normal form first. So you need to do them one after the other, always. So it's second normal form. If it is already first normal form and has no partial dependencies, so here is another way to say it, non-key attribute is dependent on only a part of the composite key. It means that if you have many columns, all of the columns should have something, some kind of a relationship in its very definition towards the primary key. If it doesn't, it has nothing to do in this table. Remember about the employee ID and its address? The address is not really something specific of the employee. Maybe more than one people are living in the same house. It's not a property of the employee. So it's not dependent really on it's a non-key attribute that is not dependent on the part of the composite key, etc. As I told you, it's a dry topic, so I'm not going to dive very deep into it. If you like theoretic approaches, make it so that you have some time to dive into the topic later. We're going to switch soon to a more practical ways to handle it. After the second normal form, you have the third one and the BCNF one with a voice code. Usually what I do when I design a schema is I try to target BCNF because it's the point where it's still useful and not so hard to achieve. And there is more, of course. You can go to the fourth, the fifth, which is projection join, normal form, and then you have DKNF, which is a step further. So I'll give you an example. If you are, for example, handling addresses in your database, so you have an address field. How deep you want to be in normalization? Are you going to do first normal form, or up to DKNF for an address field. So if you want to design it properly, because you have cities, in a city you have street names, but actually the street names, you find them in most other cities around it. So you would have a catalog of all the street names that are known, and for each street name you want a relationship with which city is actually using that street name. And then in this city, for this street name, what are the numbers on the buildings that are available in the street? Because sometimes they skip number. Sometimes you have, in Paris, there is a street where you have 4 number 4s in the street. Yeah. So I had a meeting once, and I showed up at the meeting, number 4 in the street, and oh, 4 bis, 4 ter, 4 something else, and I was, what? So I had to call them. But if your job, if you need to design an address database model, because your job is, for example, to, I don't know, either deliver things to people, or maybe you are installing fiber or electricity or phone to people's homes, and you need the exact address, and maybe you need the exact location of the box that is owned by your company and that is available in the people's home. Maybe you need to do it the proper way, and then maybe you need to do that in a way that you can then optimize the traffic and the routing when there is like on-call people that needs to show up at the people's houses. So now you need also a GIS system on top of it, etc. Now, if your business model for having the address of people is because you want to invoice them, like, you know, you generate a PDF that you send by email, but legally it's required to have the address of the company on the PDF, well, maybe a single field is going to be all you need for the address. So it all depends on the level of normal forms that you want to go in a database depends on what you're going to do with the data. If all you do is accept it and then print it again, you don't care, it's a text field. If you're going to actually have to process it and it's going to be important in your business, then you need to make the effort to make it actually possible to use it. So it's a set of rules, and you need to figure out for yourself how much of it applies to your use case. Trick is, if you're not sure, just do them all. And as you do them, there is a point where you will say, so this one was easy to achieve. This one was a little more work, but I'm happy I did it because I saw some bugs in my schema doing that. This one was more complex. I didn't find many bugs. This one was fine, but it begins to get boring, and I don't get anything out of this one. It's only adding new tables and new things, and I don't see the purpose of that. But at this point, now you have an opinion that in your case, your schema is fine in BCNF and maybe boring in 4NF. But if you don't do the exercise, you will never know, okay? So please do it and figure out at which point it gets very boring for you and stop it then. But just do it first, okay? You will be very happy you did that because you will actually find bugs in your schema each and every time. And an example is coming. It's coming now, actually. Because the way we implement those guarantees in a database is with, as we said before, database constraints. So I told you this is wrong. So who wants to win a sock by guessing why it's wrong? Yeah, I'm going to throw them anyway, but please try to figure it out. So yeah, I don't know. At the end of the talk, you will have some more if you want to. Apparently, it's really, I'm not good enough at that. So anyway, primary key means your first normal form compatible because there is no duplicates in the table, right? That's what it means, primary key. Have you heard about surrogate keys? Yes. 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 He's a DBA, he knows about it.
He talks about surrogate keys all the time.
Yes. So a surrogate key looks like a primary key, but actually it's not. It's a substitute for a natural key. The natural key is what allows preventing duplicate entries. So let's switch to this example. In the article table, the primary key is not listed here because look, it's big serial. So the ID, you don't need to give it to PostgreSQL. If you don't give it, it will be derived from a sequence. And by the way, sequences in SQL are the only SQL objects that are non-transactional, and that's on purpose. So everything in PostgreSQL is transactional, except for sequences, and that's in the SQL standard, so it's not just PostgreSQL. And if you don't know why, maybe you don't understand transactions, so you should have a look at that. I'm not going to explain. Not today, at least. So we insert category, pub date, title, and do you realize that it's exactly the same values we're inserting? Look at that. Do we have a primary key really? Because the fact that this entry is ID 3 and this entry ID 4, no single user of your application cares, right? No one is ever going to be exposed to the fact that this article is ID 3. And the only differences you have in between those two rows is the ID. So basically you have a duplicate entry. So basically the schema is not first normal form compatible. Okay? So it's really shitty. You don't do that. So how do we fix it? Well, we want a natural primary key, and then we need to understand the business model a little more. So what I did here is primary key over the category, the publication date, and the title, which means that in the whole history of the news article you're going to publish, you will never be allowed to reuse the title from the past. Well, is it your... no, because you have the publication date. So you can reuse the title, but maybe you don't want to. So you need to figure it out. So I was too fast, sorry about that. So say it again. Because there is the publication date in the primary key, you can use the same title of the article in the same category more than once at different times. Like maybe you want to react sarcastically about an article you published last year or something like that. But maybe your business model is that you never ever reuse the title, because I don't know the journalism rules, and maybe it's important for them, I don't know. So because I'm not a journalist or a chief editor or something like that, I'm not sure what should the primary key be. But the point I'm trying to make is that the only way to know is that you need to understand the business model before you do it. So as a developer, if you don't understand the business model well enough to do that, then spend a day or two with the other guys, the product guys. Or if it's journalism, spend a day with the journalists asking them how it should work. Because you need to figure it out now. And once you did that, it means that any other table that has a foreign key relationship to your table no needs to have a foreign key relationship to the 3 columns, which is not only boring to write, but also it's taking a lot of space on disk, and it's making the indexes are going to be bigger, and maybe will have an impact on the write capacity of your system, and etc., etc. So we say it's a distributed cost because it's going to be costly in more than one way, and so it's the right way to do it, but it's costly. So is there a trade-off? Yeah, I'm happy you asked. So you can use a surrogate key, which means that you have an integer here, the ID, or maybe you want to be a big int actually, generated always as identity. It's the new way in the standard to spell a sequence or a big int or something like that. So please use that spelling. It's better than using the previous one for some reasons. There is a really good article online that explains in details. If you type that in Google, usually the first link is this article, so it's easy to find out. So we will use that as a unique column, but the primary key is still that. Okay, that's the natural primary key, but we guarantee that the ID is going to be unique, so that you can use it in a foreign key reference. So I didn't write a slide for it, but now you can foreign key reference only the ID because it's guaranteed to be unique by PostgreSQL. So you can use it that way, but it's only a surrogate key, and it's made clear in the schema because now the primary key is written here, right? Any question about that? Yes. That's the usual question, yes. So I'm going to repeat it. We could do it the other way around and say this one is primary key and the other one is unique. Mostly it's the same thing, but I like to declare the intention. So your intention is that the natural primary key of this database design is here. And this one is just a facility you're going to use in other parts of the software because it's useful. So it makes it obvious that it's the case, yes. Yes, yes. So the question is about what if I have an entry there, but I need to change the publication date because it was wrong? Well, then it's going to change, yes, but not the ID. That's why the ID is useful. But the ID has nothing to do with the fact that it's going to guarantee that you reach first normal form. That's not helping, but it's helping for other purposes. So that's why it's a good trade-off. Okay.
Dimitri,
Yes.
the ID column has to be null? Not null, sorry.
Not null would be good, yes. Thank you. So you spot a bug in my slide. Here is a sock for you.
I got my sock.
Yeah, so anyone who spot a bug, you get a sock, okay? We have other constraints to, in SQL, so I will just list some of them. We did talk a little about primary keys and foreign keys. Not null, we just said it's important. Check constraint, you can have a manual check that it's not null. And there is a nice trick about check constraint. For example, each time, it's from Vic over there, each time Vic has seen a customer use a start date and an end date in a table, he found some data where the end date was before the start date. Each and every time. Unless you do a check constraint on that, the database is not going to be able to guarantee that for you, and you will have bugs, because we always have bugs, right? We just had one before. But it was in a slide, so it's okay. But in your application code, it's a little different. So mind your check constraints. If it's important for you that you have things that are, like for example, start before the end, well, maybe you should instruct the database that it's the case so that it can guarantee that for you. And then in PostgreSQL, we also have exclusion constraints. Basically, it's like a unique constraint. It's spelled a little differently than unique. But we say that if we meet with data with the same currency and an overlapping validity period, date range, which is not exactly the same as period, but we're using it that way here. Well, in that case, we want to exclude the new line. So it's like a unique index. In a unique index, when the values are the same, one of them is going to be excluded, rejected. You have an error. You try to insert, and it says, no, sorry, I already have this ID in the database. So here it's the same thing, but the rules about when do you decide to exclude the data are more complex than just an equality. There is this strange sign here that everybody knows you need to read equal, and this other strange sign here that not everybody knows that you just read it overlaps, okay? That you need to learn that once, after that you know it. But if you don't know that yet, that is overlapping, okay? Questions so far? No, okay. Denormalization is what you do when you have done a thorough job at normalizing your schema. And then you reach some difficulties in production, usually around performance, but maybe around the size of the data on disk, or maybe about something else, and you want to fix them, okay? So denormalization is an optimization technique that you implement at the schema level, at the design level, and you only optimize after it's not working good enough. So let's remind us the rules of optimization. Okay. So the first rule is don't do it, okay? And the second rule is for experts only. So how do you know if you're an expert or not? I like this definition of being an expert. It means that you have done all the possible mistakes. So when I'm telling you I'm an expert in PostgreSQL, don't ask me how many mistakes I made before. Many of them over the years. Maybe not all of them, but I tried hard. So optimization, you don't do it. And if you're an expert, you're really good at it, you've been doing that a lot in the past, maybe don't do it yet, okay? Maybe you don't need to do it, actually. The really important thing here is that any optimization is going to implement a trade-off. So if everything was easy, you wouldn't do it. So maybe not doing it is going to make your life easy. So that's the best way. And so each time you try to optimize something, you're making your life hard. So is it worth it? Do you have to do it? So how do we know if we have to do it or not? That's the classic quote from Knuth, right? Everybody have read, well, only this part usually. Premature optimization is the root of all evil. But out of context, it doesn't mean what it means actually. So maybe we should read it in full. So programmers waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of their programs. And these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered. So that's about code, but it's exactly the same thing with your database schema. If you do some trade-offs without thinking about them, you will have duplicates in production and you don't know why. You will have an end date that is before the start date and you don't know why. You will have many problems with your data in production and you don't know why. So please don't do it. We should forget about small efficiencies, say about 90, that's the trick, 97% of the time. Premature optimization is the root of all evil. We should not pass up our opportunities in that critical 3%. So how do you know it's the critical 3%? It's because you've been wrong before and you know it's going to be there. So if it was never used in production before, you never had a problem before with it, it's not in the critical 3%. So be sure to make it normalized. But when you know you have a problem, then it's in the 3%. If you're not an expert yet, it will burn in production and you will have to fix it. And after you have fixed it in production, you're one stage up in the expertise scale because you've done it wrong once, so now you're getting to be an expert soon. So how do you know it's the 3%? You know because you've done it before, and if you've never done it before, just don't do it yet. And so let's see some optimization techniques around schema modeling in PostgreSQL. The classic optimization technique is caching. So basically the cache is the trade-off in between CPU and memory. It's always been there. Either you recompute the value or you have it already in memory. So you read it from memory, done. You have the value already. If you follow the normalization rules that we saw before, you will never have duplicate information anywhere in your database. Which means that maybe you have to recompute many things over time. So let's see about how to cache data. And as soon as you cache data, you know that you need to implement cache invalidation, right? You know the two most difficult things in computing science: naming, cache invalidation, and off by once. Yes. So cache invalidation is on the list. So how do you do that in PostgreSQL? Here is an example. That's from Formula One dataset that is available as open data. It's all the races from the whole history of Formula One. You can easily have that in your database to play around with. It's an okay schema to work with. If you do that and find it, you will see that the schema is very not normalized at all. So it would be a very good exercise if you want to train to pick the schema and do the work of normalizing it. I didn't for this talk, so it's the schema that has been that is found. And so this query is, as you see, grouping by grouping sets. You know grouping sets? Who knows about grouping sets? The other guys, you don't know SQL, please, have a training or something, or look the documentation, because then developers go to me and say, yes, SQL, it's not powerful enough to do anything I have to do really, so I need to resort to Python or maybe Java or C or whatever. And if you say that and you don't know grouping sets, you're missing big. So SQL is really nice. So basically, we're going to have the top drivers per Formula One season. And how many of them, I don't know, but we are going to select only those who have more than this number of points, okay? It's arbitrary. I did that because when I did that for another presentation, then the result set would fit on my slide. So why not? But maybe you have business rules that are more important than that. So that's a query that you can run. And see that trick here? It's, you can actually do that in pSQL. It's not just for the slide. So you can have a .sql file, and then you can interactively change the season and run the query again, and it will pick the new one. So you can actually use variables in pSQL and then in your SQL scripts. Okay, that's very easy to do. So if you didn't know that, maybe have a look at it. But let's say that query is on the dashboard when the guys are logging in. So each time someone logs in on their nice dashboard for Formula One races, they have a nice updated value for the current season, maybe, or something like that. So you are recomputing this thing for every login. Maybe you don't want to do that. So maybe you want to cache the information. So you cache it by creating a view. So I do that in 2 steps. Some people do it in 1 step. I prefer it that way. So what I do is I create a view, and then I create a materialized view on top of it, because then the definition of the materialized one is select star from the view. That's easy. And then you can still use the view and you can compare it easily. So it is beneficial to use the view rather than the materialized view or the other way around. Well, I can easily compare because I have the two of them and I can use them. Who knows about left join lateral? Yeah, okay. The other guys, please, try to learn about SQL. It's very important. This thing is very useful when you did it. When you don't know it exists, you're like, I need to write some more code. And when you know it exists, that's maybe 2,000 lines of Python code here. See? So maybe that's a trade-off you are happy with as soon as you know how it works. And sorry, I don't have time to explain it now, but anyway. So now we have a materials view, and we can use it. We can even index it. So it's very fast. Now the dashboard, displaying the dashboard now is very fast. Every user is happy. But sometimes there is a new race and you need to update the results. So because the cache is invalid as soon as there is a new race. How do you do that? Well, it's a single command line. You refresh the materials view. That's it. So implementing cache in PostgreSQL is really easy. The only part we're missing is integration into the app. So in the application, you would use the new thing rather than the old one. But it's easy enough to integrate, right? You need just to think about it. Other things you can do to denormalize the schema. Some people want to have audit trails, which means that you want to have the history of all the data that ever went to your database, even when the schema changes. Because there is no application where the schema doesn't change. Change is part of the world, right? The only things that don't change are dead. So if your application never have any schema updates, it means that basically it's dead. Which I'm sorry, some application gets retired, so it's okay, but maybe it's not your intention. So you will always have new business cases, new ways of doing things, new products to give your users things. So it's alive, so the schema will change, which means that when the schema changes, maybe the old history is not compatible with the new schema, which means that you need to denormalize to be able to handle the history of the schema. There is more than one way to do it. One way that I like is abusing JSON into being an archive thing. So because the data is JSON, you can put any kind of schema into it. It doesn't care because JSON is schemaless. That's why the information is repeated everywhere every JSON entry here will have the same set of keys and different set of values. So it's really expensive on the storage. It's hard to search for, etc. But some people are happy with MongoDB anyway. I don't understand why. But you can do it. It's the same kind of approach. It's a schemaless, so you have zero guarantee. But it also means that whatever happened in the past in your history, like let's say you didn't implement your new check constraint for start date and end date, and now you did. And some of the history now is not compatible with your schema, but JSON doesn't care. It will just accept that fine because it doesn't know about what's in the JSON field anyway. So I found it useful to do that more than once. So maybe you want to do it too. Another trick is validity periods that you can implement with dat ranges. So that's, for example, rates for exchanging money. And the rates, are constantly changing. But if you're doing any finance or accounting, you need to have the rate at a given date. And what you do is that you're going to accept different values of a rate for a single currency, but with non-overlapping validity, which means that then you search the data like this. Like, how much was the euro at this date? So this operator looks strange when you don't know how to read it. So I'm going to tell you, and then it doesn't look strange anymore. So that's contains. So the validity period contains this date. By the way, using the data type name here, just before a literal string, it's called a decorated literal in PostgreSQL. So you can use that way. The other way to do it is : date, and that is a cast. So it gets the same result, but it's a little different, so date. And the thing is, because we said that we have this very strong guarantee, then we know that we will have only one record. Because given a single date, there is no way that we have more than one, because we said we refuse to have overlapping entries. So for a single date, we have the strong guarantee that there will only be one value in our database, right? So that now you can use that in your application, and you can even use that as a join condition. You can join in between the rates table and maybe the history of people who did buy or the history of your invoicing, etc. And you can match the invoice with the rate at the date of the invoice. So you can join on this, okay? That's pretty nice to have. So denormalization helpers in PostgreSQL, a lot of them are data types. Composite arrays, JSON. So JSON in PostgreSQL is spelled a little strange. It's spelled with a B at the end. Don't bother, but just remember to make it. That's it. Domains. And other tricks are like HStore, L3, Interarray, HLL. If you don't know about them, there was a talk this morning from Craig who went through most of them. So if you've been there, you know about them. If you don't, there is material on the internet to help you through it. Now that you know the name, you can actually find it, so it's easy. Another trick to denormalize your data is partitioning. You need to be really careful when you do partitioning, because especially before PostgreSQL 11, when you do partitioning, the trade-off is that you lose indexing, you lose primary keys, you lose conflict handling, and you cannot update keys anymore. So that was before. Now you can do almost everything. The only trick is with the foreign keys, it only works one way. But I'm told that maybe it will work both ways in the next release.
Do I get socks?
Yes, two of them, because you're actually implementing the feature. Thank you, Alvaro. Sorry, I lost that. So partitioning used to be a very important trade-off to make in the schema design. And nowadays it's less and less so, because as soon as we have the wool support for everything you need to implement a normalized schema, then it's not so much a trade-off anymore. But to this day, I still think of partitioning as a trade-off in the ability to implement a proper schema on top of the data. Long story short, try not to implement it until you need it, right? Except if you know you're in the 3% of cases where if you don't implement it, you will be in trouble in production. But how do you know that, right? So maybe you need it, maybe you don't know you need it yet. If you don't know you need it yet, don't do it. And if you need to do it, PostgreSQL is very good at it, so you can do it. Some people also want to compare with not only SQL solutions. And my point is that PostgreSQL is SQL, and also a part of the not only SQL movement, as I'm going to show now. So it's actually YesQL, right? They have no SQL, we have YesQL. It's way better. The third thing is you can go schemaless with a JSON-B, as we said before. So that I loaded the whole set of, Magic the Gathering, the cards game. Some of you might have been playing that before. So you can have all of them as because the data set is available as JSON. So I just loaded as it was. Because usually what you do is you load the data set as it is, and then you transform it and normalize it in SQL, because the best way to handle the data and transform it into a new representation is the SQL query language. You might have heard about it. SQL is really good at that. So first you load the data, and then you process it. So some people implement ETL, extract, transform, load. I usually do ELT, extract, load, and then transform, because once it's in PostgreSQL, it's way easier to handle. So anyway, here you see the contain operator that we saw before. It's back, but now it's working with JSON, because PostgreSQL is an object-oriented RDBMS, which means that the way I see it, you can have things like that. This operator knows how to work with many different data types, like you would do in C++ or Java or things, and you can actually write pretty simple SQL, and that is fully optimized, in this case, for JSON. Okay? It looks like a normal SQL query, and it actually implements very smart things and ways to handle JSON. NoSQL systems also usually are good at implementing durability trade-offs. And in PostgreSQL, you can set synchronous commit to different values. Okay? What people don't realize often is that it's the dynamic synchronous commit is per transaction setting. So you can have in the same PostgreSQL system in production at runtime some workload that is critical and remote apply, which means we only tell the user it's okay if we know it's been applied to a standby replica. And you can have other transactions that you don't care so much about. Maybe it's the web session handle, and you store it in the database because it's the start of the project, you don't care about the infrastructure yet, etc. And then if you lose the database, of course you lose the web sessions. Who cares, right? So it's off. You can even do that dynamically in your application, you can have here it's a trigger. Where is trigger is written here? It's a trigger that say, if the user is spending so much money, which is set in a GUC,